Okay, folks, today we're going to do a real quick logarithmic review. I can't even talk today, but that's okay. All right, we kind of went over this the first of the semester, so we're just going to talk about it really quick because we're going to use it pretty soon. All right, we can't forget that the answer to a log problem is always the exponent. All right, the answer to a log problem is always the exponent. So here we go right here. So this guy has a log on this side, and here's equal to 2. So that means that equals is your answer, so he's your exponent right there. All right, the base of the log is always the base of the exponent. The base of the log is always the base of the exponent. All right, so here we go, base of the log, and that's your base of your exponent. So this is in logarithmic form, and this is in exponential form. Okay, see how those work? All right, we went from here to here with Tiffy tails. So we always started at the base of Tiffy's tail, which is right here. So the base of Tiffy's tail is the base of the log. So that makes it 4. The answer to a log problem is always the exponent squared. Grab your equals, and then 16. Get Hopefully that's quick and easy. All right, I'm going to kind of zoom through this because I know that you can pause if you need to, so you should be okay. Sorry about the moving around. All right, so then this right here, we start at the base of Tiffy's tail, 6. The answer to a log problem is always the exponent, equals, keep going, 36. Get And that is a true statement. Now make sure you have this exponent up here high enough so that you don't think it's 62. So make sure it's high enough there. Okay, so let's try this right here. So the base of Tiffy's tail right here, 49. Grab it and go around. Answer to a log problem is always the exponent, equals 7. All right, now this looks a little weird right here. That looks a little odd, but just remember when we have this right here, we have an exponent that's a fraction. It's really just a radical. All right, and then this guy right here, so we're going to make this a radical right here. 49 goes inside. Now this numerator is the exponent of your little dude inside here. The denominator is the root of your radical. Now we usually don't write it like this because if there's no exponent, it's understood to be 1. If there's no root right there, it's understood to be 2. So usually you're going to see it just like that. That's what we're used to seeing. But we know that there's an understood 1 and a 2 right there. A 1 and a 2. Okay. There you go. I gave you time. 2 to the negative 2 power, Tiffy's tail goes around like that, equals 1 over 25. All right, so we're not freaking out. It doesn't matter that that's a negative, just like it didn't matter that that was a fraction. It doesn't matter. We're just doing what we're told to do. All right, remember that a negative exponent means that whoever you have right here, whoever's the base it is, the base is mad about where he is. He's in the top bunk right now. He's in the numerator. So that means he's mad. So really, this is really 1 over 5 squared. Now see, you brought him down to the denominator, brought him down to the bottom bunk, and he's happy. So the exponent is now positive. Equals 1 over 25. And that is a true statement. Another way you could have done this was you could have brought the 25 up. 5 to the negative 2 power is the same thing as 25 to the negative 1. I know that looks a little weird right now, but we're going to talk about this in just a second, okay? So just understand that that doesn't matter. It just means he's mad. This one right here, see the 25's on top? He's mad. He really likes being on the bottom. Okay, so that was changing from log form to exponential form. So let's go the other way. let's go from exponential form to log form. All right, don't forget the base of the base of the exponent is always the base of the log. The answer to a log problem is always the exponent. Skip a space and come out here. This dude's what's left, and so he just goes right there. Ta-da! Same as up there. Kiddo? All right, let's look at this guy. Again, the base of the exponent is the base of the log. The answer to a log problem is always the exponent. And then 7 is the dude that's left over. Same as we did up there. Kiddo? All right, let's come back to this guy. Our lovely. So we're going to say log. The base of the exponent is always the base of the log. The answer to a log problem is always the exponent. And then we have the 1 over 25 left. He's the dude that's left over. Left over. Okay. So like I said, that is from log to exponential form. This is from exponential form to log form. Now we're going to evaluate the logs, okay? So in other words, a piece is missing. So you have this piece right up here, but your exponent is missing, okay? So here we go. Let's do that. We don't have anything right here out to the side. Sometimes they'll put something out there, sometimes not. But if they don't, just say equals x. All right? Now, Tiffy tells it. 6 to the x power equals 36. All right, well, we know, hopefully you just know that that answer is 2. But if you don't, you can say in the calculator, you can go and say 6 squared, 6 to the third, 6 to the fourth, until you find that one. Usually it's not going to be too crazy, but I'm going to show you another way to do that in just a second. But 6 to So that can be done in the calculator, or better yet, you can learn your multiplication tables, just saying. All right, so this guy right here, we're going to say equals x. Tiffy tails again. So you have 49 to the x power equals 7. Now you're going to look at that and you're going to think, oh, wait a minute, this is going to be squared, 7 squared, and so x equals 2. No, the base is bigger than the answer over here. This base is bigger than this answer. So, but you can come over here and say, oh, snap, I do know that I could make that 49 as 7 squared. 49 equals 7 squared. Sorry. I could make that as 7 squared, right? And then the x is up here at the top. And this dude just comes on out here just because he was already there. Okay, well then I take this guy right here and multiply because it's an exponent raised to an exponent. So it's 7 to the 2x power equals, wait a minute, this dude doesn't have an exponent, so let's give him one. Yay me. Okay? Well, look. 7 is the base for both of these exponents. So since that's the case, you can just drop the bases. All right? Anytime you have the base is the same on both sides, drop the bases and you get the exponent. So now we have 2x equals 1. 2x equals 1. I can solve that. Divide by 2. I got you. Ta-da! So that's one way to do it. If you don't know this one right off the bat, which, you know, I'm not so sure I would really think that through. I probably would, but I don't know. Just quick and easy. Just go ahead and turn it and just see if you can get the bases the same on both sides. That's your biggest, easiest way to do it. All right, and that's going to come into play right here. So I'm going to say equals x. So I'm going to Tiffy tails 5 to the x power equals 1 over 25. All right, so now I've got to figure out 5 to the what power equals 1 over 25. Well, first of all, I'm going to go ahead and take this and put him on the top because this 5 is on the top, so I'm going to go ahead and put him on the top. So that's going to be 25 to the negative 1 power. That's a true statement. Because remember, that would mean that the 25 is mad in the numerator. He wants to go in the denominator. So we can't. All right, then I'm going to remember that, oh, well, it'd be great if the bases were the same. So I'm going to change this into, that guy just stays. This is going to change into 5 squared. Then that negative 1 is going to stay out there. Exponent raised to an exponent. You got to multiply those two together. So it's 5 to the x equals 5 to the 2 times negative 1 is negative 2. All right, the bases are the same. I'm dropping them. So that just leaves me my answer. Okay, doke. All right, so you can see that all these are all related to the same thing. You can kind of go through each individual one and see that they're all the same. They're related and how they relate to each other. Okay, doke. All right, so that's going to give you a basic understanding of changing from log to exponential, exponential to log, and then solving a log problem. Okay, doke. Have a good day.